In this video, we're going to look at the vowels and consonants programming problem from your textbook, and we're going to write a program that's a solution to the problem. So the problem tells us to write a program with a function that accepts a string as an argument and returns the number of vowels that the string contains. Okay? Furthermore, we are to have another function that accepts a string as an argument and returns the number of consonants that the string contains. And finally, the application will let the user enter a string, and it will display the number of vowels and the number of consonants that it contains. So the program basically is just going to test these two functions that we're going to write. One, which counts the number of vowels in a string, and the other one which counts the number of consonants in a string. Well, let's think for a moment about the logic of the function that will count the number of vowels. Okay, so inside the function, and let's write some pseudocode while we're at it. So inside the function, the first thing we're going to do is create a list of vowels. We'll simply create a list that contains the vowels A, E, I, O, and U. And also, we're going to initialize an accumulator because this function is going to be counting the number of vowels in a string. So we're going to have a little loop running that that calculates a running total. Okay, and then let's have a loop that steps through the string that is passed as an argument to the function and gets each character in the string. So the loop's going to be something like this for each character in the string. And then inside the loop, we're going to test that character, the character that we are operating on during that particular iteration. And we're going to say something like this: if the character is in the list of vowels, okay, so if that character appears in the list of vowels, we want to add 1 to the accumulator, and that's pretty much it for the loop. So after this loop completes, our accumulator will contain a count of all of the vowels in the string. So since this is a function, we'll return the value of the accumulator. Okay, well, let's look at how that might be written in Python code. Well, here's the code for a function named numVowels, and obviously this is not the complete program. This is just the numVowels function. So when we call this function, we're going to pass a string as an argument, and it will be assigned to the S parameter. The first thing we do is create a list named vowels, and you can see that we are populating this list with the vowels A, E, I, O, and U. Next, we initialize an accumulator. The name of the accumulator is vCount. That's going to hold our vowel count. So we're assigning vCount the value 0. Next, we have a for loop for CH in S. Now, the way that the for loop will work is that it will iterate once for every character in S. And as it iterates, a character in S will be assigned to the variable CH. So this loop will step through all the characters in S, and as it does, CH will be assigned those characters. Now, this if statement is going to determine whether CH is in the vowels list. But you'll notice that I'm calling the lower method. Lower is a string method that will return whatever CH is assigned. It will return the lowercase version of CH. And the reason that we're doing that is because I only included the lowercase vowels in this list. So I want to make sure that CH is always lowercase so that it performs an accurate comparison. So if CH is in the vowels list, if that's true, then we're going to add 1 to vCount. So after this loop completes, the vCount variable will contain the number of vowels in S. So we're going to return vCount. Okay, now let's think about how we're going to write the function that will count the number of consonants. Now, the process of counting consonants is going to be similar to the process of counting vowels. And in fact, one possible approach would be to just change our list of vowels so that it contains a list of consonants instead. And then all of the rest of this code would still work. We would just be comparing the characters in the string to a list of consonants that would be happening here instead of a list of vowels. I'm not going to take that precise approach because creating this list of consonants would require a lot of typing. I'm going to take a different approach. In fact, I'm just going to delete this and we're going to start our pseudocode all over again. Now, in the function that counts consonants, first we will create a list of vowels. Yes, a list of vowels, not consonants. Because there's only a few vowels, and typing those vowels in, that's not a big deal. And we're going to initialize an accumulator. So far, our algorithm is still the same. And we're going to have a for loop for each character in the string. So far, everything looks to be the same. But inside the for loop, our testing is going to be different. It's going to look something like this. If the character is a letter, in other words, if it's an alphabetic letter, and is not in the list of vowels, add 1 to the accumulator. And then at the end of the function, we will return the accumulator. So this is a similar algorithm. It just will not require me to retype this list and retype it so that it contains all of the consonants. There's quite a few consonants. Instead of comparing to see if the character here, when we're comparing the characters, instead of seeing if it is in the list, we're seeing if it is not in the list of vowels. So it stands to reason that if this character is an alphabetic letter and it is not in the list of vowels, then it's a consonant, so we can add 1 to the accumulator. Okay, now let's look at the Python code. So here's a function, num consonants, and it has a parameter s. And inside the function, we create a list of vowels, and we have an accumulator, ccount, for consonant count. And then here we have a for loop that works like the one in the previous function for chns. So we're just going to step through each character in the string. Here, we determine whether ch is an alphabetic letter. We call the isAlpha function, and that will return true if it's an alphabetic letter. And that's just to eliminate any non-alphabetic characters like numbers and punctuation marks. Okay, so if it is an alphabetic letter and the lowercase version of this thing is not in the list of vowels, okay, if all that's true, then we must have a consonant, so we're going to add 1 to ccount, and then we return ccount. Okay, so that is the num consonants function. Now let's look at the entire program. Okay, so here we have the main function, and we're going to get a string from the user. We're just going to prompt enter a string of characters. The user is going to enter something that gets assigned to user str. And then here we have a print statement that prints the message that string has, and then we call the num vowels function passing user str. So it prints the number of vowels, followed by vowels and then it prints the number of consonants. We're calling the num consonants function, passing user str, followed by the word consonants. So we're going to get a message that's saying that string has X number of vowels and X number of consonants. The rest of the code you've pretty much seen. Here is the num vowels function. And here is the num consonants function. And then finally here at the bottom we have the statement that calls the main function. Okay, well let's run this program and try it out. Now, it just so happens that I have already prepared a series of characters to test. I know that this series of characters has 5 vowels and 10 consonants. There's also some other characters that I threw in there that are not vowels or consonants. We've got some numbers and some this colon. So there's some stuff in there that shouldn't be counted at all. But there are 5 vowels and 10 consonants, so that's what it should tell us. And it does, says that string has 5 vowels and 10 consonants.